My name's Eddie Garman, and I'm going to talk to you a little bit about bringing tasks to the micro framework. A little about me. I'm married, have 2 boys, semi-professional disc golfer, and a professional troublemaker. Currently, I work at Volvo Trucks in North America as the specialist for future internet and connectivity. So everything related to vehicles in the future and how we have an awesome society of everything automated, everything connected. So this is a side project personally, and I just wanted to share it with you all. So how did I get here today? It's easy. I have a problem. And I think most of us in this room have the same problem. We enjoy subverting the fun of youth and injecting a learning experience. Did I mention I'm a troublemaker? Because that's what it requires. And also a special thanks to Sebastian, who really prompted me in an uOWIN discussion, who said, no tasks, there's no uOWIN. So, Sebastian, after we're done here, let's talk. So the opportunity to go after the kids was my son's Pinewood Derby. It's great. So how do I destroy their derby with an educational experience? Well, we add a jet car to a gravity race. I mean, who doesn't like that? So you can see that kids have fun, and when you get that many O faces, you've got really good acceptance tests. So, all right. So the build of the car. Simple. Don't need the batteries. So it's a pretty simple car built on NetDuino base, custom shield, and a nice little foam case just to add flair. And then the idea of the Batmobile came from my son, so he said do that. So the only requirement I had was just to be awesome. I mean, if you can't be awesome, what are you doing? But the real requirements to make this work were both to be physically small and in code as well. Micro framework, you're limited in the amount of kilobytes, not megabytes, but kilobytes of space you have available, both in code and RAM. So it all has to be as simple as it can be, or as small as it can be. It needs to be based on NETMF 4.3 or 4.2. I chose 4.3. Well, I needed a working test environment as well, which didn't exist. And a minimalist foundation. Not necessarily built on the hard classes that Spot's built upon, but truly testable interfaces. And then, ideally, I really wanted tasks because everything is just async. It's events, so just handle it as an async chain. And tasks are really good at handling async chains. So I'd like to introduce Microscuber. It's task, but not really. It's actually the name of the project that I did all of this under. So first of all, what is a scuber? A scuber is a throw in ultimate frisbee, and I've spent 15 years throwing discs. So I thought it was a good name, right? Micro being small, and scuber is one of the best utility throws in ultimate, so I thought it was appropriate. And the cool thing about it is it's a rethought of the development methodology in a micro environment. We don't necessarily need to have big 2 megabyte libs that we use 0.1% of the code in. That mindset for developing in a micro environment doesn't work. So yeah, don't consume anything you don't need to. We need to start with a shared definition in interfaces, not a shared definition in abstract classes. And we need to be able to pull additional components in as source specifically, so you only pull in what you need, and then it gives the developer the ability to edit to their content. And then the best thing is use Nuget to make it available and discoverable. So the test framework, inspired by Brad Wilson's xunit, so it's based off of using naming conventions for facts and theory discovery. has a pluggable feedback mechanism as opposed to just a generic remoting mechanism. So if you want to run in the emulator, you can use that feedback mechanism. If you want to have a character display, you can use that mechanism. If all of you have is your board, such as the GHI board here, with the LEDs on it, you can actually use that LED on board to give yourself the feedback to validate that your tests are passing. And then, most importantly, you got to have build time automation to make all of this work. And so here's just a couple of little screenshots of the user interface of the test environment in the emulator and the agent emulator. Let me swap over. Come here, mouse. Sorry. If I swap over. So for testing, you have your code and your projects, and so you've got your test projects. They reference the test framework, and then you add your code that's your test code, and then for the most part, you define this one entry point. So you define your test harness and specify the feedback mechanism. And then when it runs, it gives you your full user feedback as it's going along. So this is the core tests for the framework, and it runs really fast. If I want to change and run the Right, where are you at? There you are. And then same thing, the test for the tasks implementation also works. Well, maybe not. Oh, it does if I turn off. Yeah. I'll be quiet. If you intentionally throw exceptions in your test to validate with the negative testing, don't demo and show with that checkbox on. And you can see as it runs through, it gives you an update of which test is running and the total status of passes and fails. And because this is micro framework, the implementation under this with the testing is all done not in the optimal way of building up a new app domain every time and being able to destroy it. So that's one of the downsides. Eventually, at some point, we'll get to where we're hosting in separate app domains for every test. But all right, so automation. It's more than just the build process. And in Microscuba, I used Saki, PowerShell, C#, Nuget, and the NETMF emulator. So the cool thing about Posh is it actually lets you bring the goodness of C# into it and build what you want to do. One of the cool things that I found is creating a separate project in Studio that's a console app, and all I do is I put my classes that I'm going to use in my build in there so I can get my full Visual Studio environment around me, so building and testing and making sure it works. And then, as I do here, I just import the type directly as code from a file. So just read it in, go, and now I can pull in whatever classes I want dynamically in my build process. So as I've done here, I've got a class that wraps up the Symverse semantics for doing automatic build management numbering. And back over here. All right. So within the build, I've got my Posh type definitions right here in a project with my script. So it's all in one spot, nice and clean to get to. So So there's the class, and I just pull it in and use it. So again, do automation for testing, for versioning. One of the tricks that I found when I beat myself up using my own work for the car was when you're doing your 0 versions for development, make sure you use the dependency range as whatever the current version is all the way to 1.0, and then you just get whatever's there. And otherwise, if you try to limit yourself, you really get hampered by the way that Nuget implements the range restrictions. So this is just an easy out. And then once you get a 1.0 implementation, going back to the standard semantics of major, minor, revision, it's great. It's just an easy way of doing 1.0 consumptions. And then the other fun part is, well, you've got an emulator. How do you actually do your test in the emulator? Well, you got to load the code. You got to load everything that's dependent for that code and get it all packaged up. And as a part of that, well, you have to do a bunch of reflection. And if you do that in your building process, you can't keep building. You crap all over yourself. So you have to really do a good job of hosting that in a separate domain so you can do your reflection and then unload, run your test, unload, do your reflection, unload. So again, automation is key. All right, so now to the fun part, tasks. So the intention of this micro framework task implementation was to do the best job to semantically mirror what Microsoft has done in the full framework. So cancellation should be the same, execution should be the same, exceptions should be handled in the same way and observed in the same way. And when you have an unobserved, do it like the new version of TPL and don't crap out on the device. And again, it's a smaller surface area, so there are a few things that don't make sense on a microenvironment. Well, obviously, microenvironment, there's no generics, so it makes it a little bit harder. So you can't say action and func of T to work around things. So you have to define everything down at the delicate signature level. So cancelable, action, cancelable function, and unobserved handler. And they're all the same shape as what TPL does. So task T is out, and therefore you have action task and func task. Where func task just returns a object result as opposed to a typed result. So you have to cast. It's not that bad. I never liked the task.factory pattern. I mean, you don't need to call a factory. Mothers are not factories. We don't call them factories, so why do we need to put that name in there? And then new and run are similar to the other one. Always be able to create completed tasks, so canceled, completed with a result, or a faulted task. And then with continuations, now again, it's just a definition of another set of delegates. So you can continue with an action, or you can continue with a cancelable action, both on an action task or a function task. So it's just definitions are there, the compiler takes care of it, and you go. The value of lambdas in a good compiler. Awesome. So task.run, continue with, and now we can continue to chain, and we can do just like we do today on full framework. We observe exceptions the same way. So always when you access the property of the exception object on the task itself, we mark it as observed. We always observe it when we wait or call result. And then, similarly to TPL, we also observe it when it hasn't been observed at disposal, which causes the unhandled exception event. Batching task is still supported. Wait any, wait all. That's really good for watching multiple sensor inputs to come in and figuring out which one, or you don't care which one, you just need something to continue. So it's a good way to orchestrate those events. All right, so the bits. They're up on GitHub right now and on Nuget. So if you want to play around with them, that's where they are. And I would encourage you to do so, and I would love as much feedback as you can give me. It's early in the process, but I'm looking for any and all ears, positive and negative. So yes, does it work?
That would have been faster than what my slides was.
Thank you. So with the car and the devices, you can do a lot of cool things. But to make it easier for yourself when you're doing development and tasks and all these things, another bonus is to make yourself a mock, both in code and in hardware. So I have my car and its components, and then even with testing, you know, build yourself your same input panel and plug it in. And then it's the same concept that we do in our other unit tests. But now you isolate yourself and make it really easy. So just to show you an example with my battery. So this has all the same sensor inputs and user outputs as the car does. I'll show in a second. So a couple of buttons to change your modes, to select your power, and then of course the lights. You know, kids love lights. And then if you interact with it, you can get your different modes. Come on, too much light on the stage. Wow, bright. Well, that demo didn't work. Yeah, there's a photo cell that I'm using because the way the track was set up within the race, you're not allowed to actually have driven motor power on the axle, and you can't damage the track, and you can't have an external starting device. So I used a photo cell on the front with the pin, so when the pin falls, the light comes, it turns itself on. So I have a task that's sitting there watching, waiting on that event. When that event fires, get out of the way. So the code for the actual car itself is actually very simple. I just create my class for my NetDuino and then hook up the different triggered events. And then I set up my tasks. So my light manager is a task. It does all of its special code. And then the executing piece is a string of tasks. So when I'm inside my execution, I'll sit and wait on the trigger to occur, and then I will run a task that pulls the sensor in the front. When it sees that, then it triggers the next task, which actually runs the car. So, and with that, sorry for the delay. This is going to take a minute. I can run the video again if you want to watch it. But this is the value of having a hard to put together demo. All right, so that, this. All right, so with the car, it's the same things, right? The sensor's on the front, my input panel's on the back, and let's have some fun. Thanks. So my intention was to break it today, so let's see if we can do that. All right, so maybe that didn't work. We'll try again. Well, maybe I won't. It lost some wheels.
You break it. You broke it.
I still wanted to fly. It's more fun that way.
Maybe you need more tension to that cord.
Who needs wheels? Oh! Yeah, I need wheels for a ramp to work. Yeah. Sorry about that. I'll need about 2. So I really only have 2 challenges that I'd like to offer out to you all. One's easy, one's hard. I'd like help. That's the easy one. But more importantly, challenge yourself to inspire the kids, because without them, there's no more of us. So, thank you.